Hi folks, this is Linear Algebra Quiz 13. We're given a function from P2 to R3. Here's the formula for it. We're asked to prove that T is linear. So what do we need to show that T is linear? So T is linear if T preserves linear combinations. In other words, T of alpha V plus beta W is alpha T of V plus beta T of W, where V and W are fixed but arbitrary choices of elements in the domain, and alpha and beta are fixed but arbitrary choices of real numbers. So let's let V and W be fixed but arbitrary things in P2. So what does that look like then? Then V looks like some AT squared plus BT plus C, and W looks like some DT squared plus ET plus F. Let's let alpha and beta be fixed but arbitrary real numbers. So what I want to do is compare T of alpha V plus beta W, alpha T of V plus plus beta T of W. So alpha V plus beta W. Well, I'm going to multiply this by alpha, so I'm going to get alpha A T squared plus alpha B T plus alpha C plus beta times that polynomial combine the like terms. I get alpha A plus beta D T squared, alpha B plus beta E T plus alpha C plus beta F. And so, by definition, T of this guy is going to be what? Well, we take the leading coefficient, that's what goes in there. So this is going to be leading coefficient alpha A plus beta D. Then I take the leading coefficient plus the coefficient of T, and that's what goes there. So I do that. The leading coefficient plus the coefficient of T. And then I take all three coefficients and add them up. Oops. Yeah, alpha B plus beta E plus alpha C plus beta F. Okay? Now what I have to show is this the same as alpha T of V plus beta T of W? So let's look at alpha T of V. Well, that's alpha T of AT squared plus BT plus C, which is alpha times this. Now I can distribute that alpha through. I get alpha A. I get alpha times this, which I can write as alpha A plus alpha B. And I get alpha times this, which I can distribute alpha A plus alpha B plus alpha C. I take beta t of w, which beta t of dt squared plus et plus f. So that's beta times d plus e, d plus e plus f. And I distribute that through beta d plus beta e, beta d plus beta e plus beta f. So now if I look at alpha t of v plus beta t of w, what am I going to get? Well, we add these vectors component-wise. So alpha a plus beta d, alpha a plus alpha b plus beta d plus beta e. And then all three of them here. Alpha a plus alpha b plus alpha c plus beta d plus beta e plus beta f. And you can check that if you rearrange terms, that's exactly what you get out of alpha t of alpha v plus beta w. So this says that t is linear. And that'll do it for part A.